Okay, so in this task we are going to add support for multiple concurrent clients. Just to recap, in the previous task we made the server that will respond to multiple ping commands. So show you the code. This is the code. We create the server, bind it to 6379, which is the default server that the actual Redis server use. We receive data, and then as long as the connection is up, we'll continue to receive data, and then if that data has ping in it, has the command ping in it, we respond with the pong, and then continue to receive data as long as the connection is up. We can try that. We can see if it's actually working or not. So here we run it, and then let's connect to that. So we're connected to the server. If we send hello, nothing comes in, but if we send, let's say, ping, we'll get pong. As long as we are connected to the server, it's gonna be running, but as soon as I close it, as you can see here, it got closed. But this is only for a single client. What we are going to do now in this video, which is add support for multiple concurrent clients, there are two ways to achieve this. One is using threads, which is for every client that gets connected, we create a dedicated thread for that client, or start a dedicated thread for that client, and then do whatever they want. Then, or an efficient way, a more efficient way than threads, which is an event loop, which is what I will implement now. So event loop, the official Redis implementation, does use event loop. I made a little sketch that will I hope it will show how event loop is better than threading. So in threading, for every client, easy stuff, we connect to the server and then create a thread. For every client, we create a thread, and then each thread uses their own memory. Each thread runs independently of the other threads. But in an event loop, we have only a single thread, but we'll implement an event loop and then a task queue, which is basically when a connection starts, the event loop notices that connection, and then let's say when it registers that connection, and then when a command comes in, the event loop notices it, process the command quickly, and then move on to another connection that's sending commands. So it will handle this very, very efficiently and on a single thread, which will be much more efficient and much more lightweight on system resources than event loops. A good analogy that I read online, it says the extremely efficient receptionist. It's like, imagine it, there's this receptionist that's handling multiple clients at once. Maybe she takes a document from this one, listens to that one, and then figures out something on laptop. She's very quick, and then she's handling everyone at once. Not at once at the same moment, but she manages to, let's say, handle the client this quickly, and then go to the other one quickly, and then comes back to that client quickly. That's how an event loop works. So this is what we have. This is from the previous one. We just single client. We respond to a ping command. So in Python, it's pretty easy to let's just pass for now. In Python, it's pretty easy to implement an event loop, which is an asynchronous, using the async IO library. Implementing it from scratch is tedious, and using the async IO library is much better and easier. It's also a very good library. It does the asynchronousness very well. It manages very well. So we just import async IO, and then let's create the class. I'm trying to speak quickly to to make this video as short as possible. So let's create the server class. I've already done it, as you can see here. I've already done it. I'm just gonna show you how I did it. So let's just the init class. So the init class, we're gonna have a host. Let's default it to localhost, and then we have a port. Let's default this port also to 6379, which is the default Redis, the default port that Redis Server uses. So what we're gonna do is self.host is going to equals to host. No, I don't want to do that. Host, and then self.port is going to equals to port. Okay, we can do this, and we'll have to have a start method that will start the Redis server. But we need also another method that will handle the connections for us, handle the reading and the writing process. So we're gonna create it as sync. It's gonna be, of course, as a synchronous method. So sync, let's call it handle client. So this handle client is gonna have a reader, it's gonna receive a reader object and a writer. This writer object will be from a sync. They have it. Yes, stream writer. Also the reader is going to be stream reader. So this is the beauty of async.io. It's very well developed. So let's create a try catch block. Let's try, and then let's create an infinite loop that's going to run forever, which is like the previous one. I said while data, we will continue to listen for new clients and commands as long as the server is running an infinite loop. So the data will be an await. We will await the reader. We will read. Let's just do this, and then if there is no data received, that means the connection is lost. So we're just gonna break. Breaking will of course stop the loop, thus stopping the whole server. And then the response, not responses, what did I do? No, okay, response, no, yes, okay, the response would be in a wait. So here we can do it from here. We can just say we can implement the commands, command handling from here, since now we only have we have to respond to only the ping command. But let's make another method for it, just for the future, because we'll be implementing another command as well. Let's do let's do process command. The process command will take data encode. Okay, not encode, decode. What am I doing? We're receiving bytes, so we're decoding it. So we'll do this. We will do this process command just in a second. But here, if there is a response, if there is a valid response for the command that we just received, or the data we are going to write here, it should be double D, just for not double T. I'm sorry, I guess okay, English is my second language, not actually Mexican, my third. So writer, we're going to write the response, okay, and then we'll await. We'll just drain operator, clean so that we can continue with writing for other clients, for other connections. So let's accept, let's just do all exceptions as E, and then let's just print them for now. We can do some fancy logging later. And then finally, after everything is done, we're going to writer close. Let's close the writer, await writer dot wait close. So we're gonna make sure that everything is closed gracefully. Now let's implement this async process command. We're gonna have self, and then we are going to receive a command. Okay, this command is going to be a string, and then now we only have to respond for the ping command. So if ping in date and command, not data, we are going to return which is the pong /r/n. So of course we need it to be bytes, not a string, because we are going to write it quickly. Or we can just do this and then respond to the code, because it doesn't matter, it works either way. So else we're just gonna return none, so that none is not gonna write anything here. If none, it does not work. And then finally we implement the start method to start the server. We are going to create the server, await start server here. So in the start server we are going to pass the self handle client method, because we're going to receive the reader and the writer and everything. It's going to handle everything for us. It's that easy. And then we will pass it the host and the self port. Async IO. They're just closing everything. Okay, needs to be like this. Okay, and then we're going to await server forever. We're gonna just run forever. Now finally here, Redis server. Let's create an instance of this server. Redis server. Okay, and then let's just run it. Async io.run Redis server .start. So just to recap, I know I may have gone quick, but it's for the video, so you can go to async io. It's a very, very good library for asynchronous stuff. Async library, concurrent code using asynchronous syntax. It's very, very awesome, and they are updating it very frequently. So just to recap, we're defining the host, the port, and then here we are reading, and then we are processing the command. And then if there is a response, if the command is a valid command, we will write a response. Just that easy. And then we start it. There's no complex stuff about this. It's very easy with this library. That's why Python is so awesome. So we can just test it, test if it's working, because Codecrafters API. Let's just see if it's okay. Okay, test passed. So that's how you make a server that's gonna a Redis server, not just for now a basic server that's gonna accept multiple clients concurrently with async IO. That's it. Thank you for tuning in.